well, the recording. So to start things up, my name is Daniel Hinchliff, and I work at GIZ on sustainable waste management and circular economy. And I also coordinate our Prevent Waste working group on e-waste management. So today I will be moderating us through the program, and what we have coming up is essentially a brief overview on Prevent, if you're not familiar with it. We want to go through our participants, understand who we have with us, what are some of your challenges, what's your experience with e-waste plastics, and then we get into the main content, which is being delivered by Mario Champagne, who will be explaining us how to identify different types of plastics from e-waste, how to sort them and recycle them. We should have plenty of time for discussion and answering more specific questions as well. Please feel free to post your questions into the chat, and we will then address them. You've all been put on mute for the moment, but when we get into those discussions, also happy to unmute you if you would like to speak up. And the survey, just to know who you are, I'll post it again into the chat. If you haven't filled it in already, feel free to go and take a look at that. If you already know the Prevent Waste Alliance, maybe you joined our trainings last week, so you already saw this presentation. So feel free to have a look at that, and I will let you know a little bit about Prevent. So Mario, next slide, please. So just for bandwidth issues, I will also turn off my camera. But the Prevent Waste Alliance was launched in May 2019 by the Federal Ministry of Economic Cooperation and Development in Germany, that's BMZ. And what we are is basically a platform for international exchange and cooperation in the field of circular economy. We have a focus on lower middle income countries, finding solutions for waste in these contexts. And as we speak, I think we have over 240 organizations from different organization groups, so private sector, academia, civil society, and public institutions. Next slide, please. So I think I can't see it yet, but the next slide will be about our mission, which is essentially to contribute to the circular economy worldwide and support that this can happen through minimizing waste, eliminating pollutants, and reutilizing resources in the economy. Next slide. Then there's a bit of lag on my side, so I will do it from memory a bit. But we have 3 working groups. One on plastics, and this is much more looking at plastics from packaging and how we can set up recycling activities for these and recycling systems. Today, we're looking at e-waste plastics. So this is actually a training stemming from the e-waste working group, the one in the middle. And this is which I mentioned before. This is the working group that I'm coordinating with some colleagues from GIZ. And we have about 65 members in the working group on e-waste. And this project today is part of that. We also have a working group on framework conditions, where we look at different ways to support sustainable waste management at the municipal level, the framework conditions such as financing and policy. We also have a few other activities ongoing on awareness raising, behavior change, looking at extended producer responsibility, and also plastic credit systems. Next slide, please. So we have, at the moment, various activities ongoing in the e-waste working group. We have pilot projects in 3 different countries. So we start with Innovating Quito. This is looking to set up an EPR system in Ecuador, in the city of Quito, to support their circular economy strategy, but also a collection system which supports recycling of e-waste with some collect and learn vehicles, also awareness raising. In Nigeria, we have a project which is called Econ. So it's looking at e-waste compensation models, how these can support the development of a local treatment solution for lithium-ion batteries and screens, monitors, particularly how this can be complementary to non-operational extended producer responsibility systems, or how they can be complemented when they go online. And in Tanzania, we're also looking at how to support authorities manage their imports, particularly of e-waste and used goods, used electronics, how this can be better managed. In the last year, we've also set up a working group, which is looking at how we can overcome difficulties with exporting e-waste from lower middle income countries to, let's say, industrialized countries or to appropriate recycling facilities abroad. This is often very challenging with the Basel Convention. So this is something we're looking at. How can we support actors, particularly recyclers, trying to export different e-waste fractions from a country, let's say in Africa, to Europe? How can we make it easier to do this? Because at the moment, there are many legislations from the Basel Convention which may be badly implemented locally, and we can try to support that this happens faster and cheaper. So we're trying to gather experiences at the moment. But yeah, the main thing today is that we're coming from this pink project up in the left corner, which is finding solutions for problematic e-waste fractions. Within that, we've been looking at developing some pilots for foams from refrigerators, for batteries, and we had two trainings actually on batteries last week, one in English and one in French. And this week it's plastics. So we're having a training today in English and on Thursday in Portuguese in Brazil. How can we deal with e-waste plastics, which actually can have a value, but are not always finding a market locally or internationally? So how can we try to help that be developed? So next slide, please, Mario. I think that's it actually. So that's a quick overview of Prevent and the activities we're doing on the e-waste working group. And with that, I can hand over to Mario, who is going to lead today's presentation, today's training, and give you any more information that we need. Thanks. Over to you, Mario.
Thank you very much. So good morning, good afternoon, or good evening, depending where you are. My name is Mario Champagne. I'm a chemical engineer, and I'm working for the Landbell Group. I've been requested by my colleague who are working on a e-waste project to help plastic recycler in Brazil to develop a kind of training session about plastic. My experience is more related to WEEE and batteries than plastic recycling, but there is some connection regarding this. My job mainly in the Landbell Group is mainly to organize audits and verification of compliance of recyclers that are working with us. So I have seen a lot of plants related to electronic waste and waste batteries in many countries around the world. Well. And it's an opportunity also to say that the Landbell Group is a company that is involved a lot with packaging waste. And for the ERP recycling platform, we have some national enterprise located in 15 countries where we manage WEEE and batteries in these countries. They are called compliance schemes mainly. There is a lag, I guess, when I click on the slides, probably some seconds. Sorry about that. I have a very low connection. Working from home, and already apologize for eventually my colleagues. I have two, they are sometimes barking, so it's difficult to control. The summary of the day, we'll talk about the types of plastic, some identification tips, very quickly about the environmental health and safety aspect, emergency situation, collection, link storage. Mainly, there is a long section about how we can sort these plastics, and also a section about recycling and disposal of the type of plastic that we don't find any solution for. The type of plastics. So nowadays, we can find plastics in all aspects of our life, They are ranging from packaging, pencil, toys, cars, phones, refrigerators. They are everywhere. And the one thing about plastic, they have a lot of qualities. They are cheap, easy to transform. They are very solid. They can resist over time. They have a long life, durability in general, if we are taking care of it. And they are also recyclable, which means lowers carbon footprint eventually if we integrated them inside the manufacturing process. as a second-hand raw material. So, but sadly, plastic is not always well understood by the recycling industry. It's a complex mixture of a lot of things because there is so many types of plastics. And also there is an issue about bad management of these plastics. For sure, we can see a lot of packaging waste floating on the sea. We are all aware of that, and people are putting in place systems to recover them. That's good. But also on our side with plastics, there are some opportunity to develop because there is something to do with those plastics. It's not waste. I mean, most of it is not waste. So why should we identify plastic and try to sort them? And why is it good for the planet? Mainly, it's a prerequisite to enable safe and environmentally sound management of this material that is not natural. Some of them contain hazardous substance. We should aim to remove them because there are some hazardous substance and they need to be removed. We aim also to protect the environment and, by the way, life. And we need also to protect the assets because those materials, they have a value, so they could be eventually used as virgin material to be recycled. I talk about carbon footprint. It's important because if you use less virgin material, you will save eventually money inside the manufacturing process, and it's less loss in the nature. Also, why it's good to sort, it's if you are an e-waste recycler, eventually you can get some money from it. You can aim at some profitability. We know that some plastic have value, some have less, we don't have at all, because of the presence of some elements in it. But sorting is something that is easy to implement. If you get your own experience on it, there is a learning curve, but it's easy to learn, honestly. And this is something also that could be implemented very easily in low and middle income countries. But now what we will look at, we will check what are the types of plastics, how they are classified, things important to know about it, and the one that have some values, because I guess this is one aspect that will interest a lot of e-waste recyclers. Click. So the ideal plastic cycle for it's all start from the we collect. We collect a lot of small domestic appliance, fridge, TVs at civic amenity sites in Europe. It's probably the case also in your countries. Somewhere somebody is collecting those equipment. If we could recover those plastics and small flakes and provide them eventually to people able to transform them, to make some pellets of them, eventually those pellets will end up in manufacturing process to create new equipment. And we have a cycle. So in general, it is known that there are like 15 types of plastic in we. There is probably more, depending of different element that we found inside this type of plastics. But the idea really is to create a cycle, a perpetual loop where the things could be reused. Some fact about plastic from Europe. It is known, I found information in the very nice studies. I have the reference at the bottom in the corner. The number are quite impressive. There is a 2.6 million ton per year generated of plastic in Europe. Among these plastic, there is only 1.3 million ton of wheat that is collected. 1 million is sent to plastic recycler or smelter for the one that is, that we found inside the Prince Rupert barn. And there is like 300,000 tons that are sent for incineration, energy recovery, or to be used as a substitute for fuel in cement kiln. But there are also some losses because when you shred sometimes you have some piece of plastic that are stuck to metal pieces, so eventually it will be lost somewhere in foundries. And there is also some part that are going to landfill. So the half of wheat plastic are lost somewhere, not going through official channel. So it's going through the bin, the waste bin. They are going to substandard recycling facilities, meaning sites that will collect plastics and they will make big pile of it, and it will stay there for a long period of time. I saw it recently last week on TV in France. There it was a TV program showing like those kind of dead area covered of plastics. It's wrongly managed. There is fly tipping, people throwing stuff along the road, quite common in many countries. And also a lot is exported. Voilà. So wheat plastic represent an average 25% of all wheat generated annually by weight. And it's really a complex mixture of different polymer containing a wide range of additives. Again, another very nice schematic from the study that you can see at the bottom in the corner. Those people have made a very nice job to show per type of wheat what are the main plastic types that we can find inside the electric equipment. As an example, if we take a look at the first one, the fridges, we can see that most of it is high impact polystyrene and the result of polyurethane also. And there are some polypropylene. And if we are taking a look at the screens, the result of ABS, high impact polystyrene. Voilà. One thing to mention about ABS, there is some that we call BFR ABS. These are brominated fire retardants. So these are elements, type of plastic that we try to spot and the we collect in Europe and remove it from the chain to get destroyed, because these are considered persistent organic pollutants, and we aim to destroy them. We will talk about it later. We have some special slides to explain deeply what is this brominated fire retardants. So we can see that ABS, polypropylene, polystyrene high impact, and PC-ABS are the most found polymers in wheat, and they represent 75% of all wheat plastics. 25% consists of various polymers, including polyurethane, polyamide, and PVC. This graphic has been generated by using 800 data points that were compiled from studies coming from a lot of people. We recyclers, we plastic recyclers, and also compliance scheme, which means that this graphic is quite precise, I would say. Yeah, well. So plastic are the main component of wheat, but the problem faced by recycler is the large number of types of plastic with very different properties that depend on the content of the chemical resin and the presence of additives that are incorporated to improve specific properties. I already talked about flame retardants. I was told once by a guy specialized with plastic from TV that there were more than 45 types of BFR plastics found in the housing of the CRT TV, which is quite impressive. There are also fillers, pigments, stabilizers, things that we will develop in the next slides eventually. So we can see that, yeah, the brominated fire retardant, it's well known that the old CRT TVs were containing a lot of it. And also for the cable, there were some presence of lead, phthalate. These are additive that we found in the cables to make sure that the plastic doesn't fall apart, get brittle. It's to give it some kind of, to the material, a kind of flexibility. Sorry. Chemistry in identification tips. So there are mainly three family of plastics that we can find. There are the thermoplastic, thermosets, and elastomer. The little image of the bottom explains quite rapidly what they are. The thermoplastic is a very flexible and moldable plastic that can be transformed very easily every time you want. Because of its polymer chain, we can rework them very easily. Compared to the thermoset, where you will have something that will get very, very hard, very rigid, and transformation in the future is quite difficult. You can imagine with a bowling ball that it's complicated to do something with it. It's so hard. And elastomer, ben, this is like all the gasket and polymer rubber that we find many times in the WE. So thermoplastic, we are finding a lot of them in the WE fraction, and they are very easy to recycle because they can be melt and mold again. I already said that there are 15 types of flaccid observed in the composition of WE. There is a nice presentation here, a pie chart that shows the distribution of the plastic type. We can see that high impact polystyrene, ABS, and other thermoplastics, they are mainly the main component of the WE plastics. What manufacturers are wishing, they want to eventually to get clean sorted plastic loads that would be probably handled through some kind of compounders or enterprise able to create some pellets with good quality, good properties. This is a topic we will discuss later as well, how we are reaching that goal, okay? Because if they want to incorporate eventually second-hand raw material in their products, they want to make sure also that the new product they will create with a recycled fraction will have a good life and will satisfy their customers eventually. Voilà. A quick look at something that is probably not really related today because it's packaging, but I believe it's important as well to know that there is a system for packaging that is probably well known because everybody is recycling packaging, I guess, at home. And we found a lot of them and many types of bottles and equipment. So there is a list over there for your information with the description, and you can see that there is like a code numbers identifying the chemistry of it. It's not. I believe it's pertinent as well because if I have an example, if you are a e-waste recycler and that you're dealing with a B2 enterprise business that have material that is already in some boxes or bags, when you receive the material, you would probably look to recycle those material as well. I have an example here. It's a case where there is a customer sending to us some computer bag in a box, and there were some endo that could be recycled. You know, we can see that in this case it's HDPE, so it's not to be neglected. The marking of EEE plastics. So that's an interesting section because we saw that packaging, they have marking, but WE plastic as well may have some marking. And this is coming from some ISO specification. I have put over there the reference. And if you had the chance eventually as a e-waste recycler to open some computers or some Nintendo, PlayStation, or whatever, you will see inside the equipment that there are some markings, sometimes very, very long, as the one as you can see at the bottom of the page. So there is a meaning about those codes, mainly, that could help you eventually to make proper sorting. Eventually, you will see that large pieces, in general, are very well identified. There is something written. It's not sure for small pieces. Sometimes myself, I'm dismantling a lot of equipment just for fun, you know, for my work. I've seen that very small pieces can as well be marked, but sometimes you need to have like a magnifying glass to be able to see it, so it doesn't make really sense. It's like it's written, but you ask yourself why. And sometimes also the pieces, the way they are made, if it's like a little wheel or a little gear, it makes no sense to be marked because there is no physical place to put like a very long marking. So mainly what those markings are telling us, they are telling us what is the nature of the plastic that we can find over there. If there is a flame retardant that has been used, implemented in this plastic. Is there any filling or some material to reinforce that plastic? Is there any plasticizer used? And can we find in it some kind of recycled content? Mainly. If we take a look on the right, we can see as an example, ID material, ABS, between two little arrows. This is always marked like this, okay? So there is a mixture, there will be a plus. So this is like two types of plastics mixed together. If there is some laminate, because this is happening sometimes, you have some layer of plastic joint one over the other one, and this is giving this type of marking with Ppma. Is there a flame retardant? This one is quite obvious because it's easy to read. FR for flame retardant, and 40 correspond to a type of flame retardant. Is there any filling to help to reinforce the plastic? In this case, GF is for glass fiber. In this case, they tell us, it is telling us that there is like 10% of it. Plastificant, oh yeah, it's plasticizer, I'm sorry, this one is in Brazilian. So in this case, yeah, you see in parentheses, P for plasticizer and the name of it. And the last one, 85% of recycled material that will be found in this type of ABS. Voila. However, we have to pay attention. Some people advise us that some manufacturer of plastic part, people doing some molding of the material, sometimes they use old mold, and the marking may not match what is really used as a resin. So that's why it's necessary at the moment to make additional checkup to make sure that we have the proper stuff in our hands, which is making the thing a bit complicated. So we need to make controls. I have here some example of real life material, you see. This is coming from equipment I am dismantling myself. So we can see that it's clearly indicated, like that there is polypropylene, ABS between the two little arrow. You have a little wheel here. It's a white plastic. It's written Ppma. I have the complete name. Next slide somewhere. I don't remember. And also here we have a piece of optical reader. What it's a PC plus ABS. So there is a mixture of material with glass fiber 30%, and there is the flame retardant 40, which is an organic phosphorus compound, which is halogen free. So it's a good fire retardant, because there are some good ones, and maybe there are also some bad ones. So we are aiming to find the bad ones. So we talk about a lot of stuff that we can find inside the plastic. We call them additives and fillers. In general, they are organic or inorganic compounds that are introduced in the plastic in order to change the properties of the plastic. Most plastic in their original form are impact resistant and durable, but often they are brittle, hard, combustible, or too heavy for the use we want to give to them. So mainly, we find those type of additives: flame retardants, filler, pigments, and stabilizers. Let's look at it. Fire retardant. We are talking a lot about it since the beginning. So the fire retardants, they are there to reduce the flammability of the plastics exposed to high heat sources. So where we can find them inside the WE, by experience, I have seen them near as like the cover of power supplies because there is potential heat source there. And also optical readers and cathode ray tube monitor housing as well. It is not limited to this. You can find a lot of plastic parts with this potential presence of brominated fire retardant. We can imagine like near the scanner of the lamp of a scanner, maybe a coffee pot. I don't know. We need to dig. Anyway, that's why, in general, recyclers, when they recover plastics, they shred it and they will take samples and they will verify the presence of BFR. There are some tests we can do. This is also something we will discuss later. So the BFR, some of them are classified as toxic and need to be disposed in hazardous waste incinerator in Europe. And this is an option that is not really always available in low and middle income countries. But it is important to sort them, to remove them of the recycling streams because we need to end that vicious aspect that it's always coming back in in our life. You know, we need to get rid of them. We will explain why they are dangerous also in a few minutes. And just to say that we are doing a lot of work with recyclers in Europe to remove them from WE. We started many years ago with a threshold of 2000 ppm accepted and the plastic coming out from the plants. Now we are at 1000 ppm. And I guess with time, as they will find a decline in the concentration of this material and the WE plastic, it will probably go lower with time. I guess it is the aim also of the EU as well. POPs and the Stockholm Convention. So the brominated fire retardants, they are there. We talk of polybrominated diphenyl ethers that have been used extensively as flame retardants in the plastic components of the electronic and electric equipment over the years. They are considered as POPs. What is a POPs? It's an organic chemical substance that persists in the environment, will bioaccumulate through the food chain, and pose a risk of causing adverse effect to human health. It's like a PCB oil, you know, from transformator. You know, this is falling somewhere in the nature. One little beast is contaminated. The little beast is eaten by another bigger beast. At the end, the bigger insect is eaten by a fish, and you eat the fish and you get contaminated. So it's not lost in the food chain. It's accumulating. So when we talk about the POPs, we talk about those material, tetra BDE, penta, hexa, and hepta BDE that were listed as POPs in 2009, and deca BDE was added in 2017. So the EU POPs regulation has implemented the Stockholm Convention and set a maximum concentration limit of 1000 ppm for the total concentration of these material, these POPs. And when we find these POPs above the maximum concentration limit, they must be treated in such a way that we are not finding them again in our processes. They have to be destroyed, okay, or irreversibly transformed. Although the use of PBDEs and EEE has been banned from 2008, and also many manufacturers have removed them from their processes, they are still present in the WE that we are finding today. So it's not lost. We're still finding them. For sure, this is Europe. I don't know, maybe in other countries, on other continents, for the moment, it's probably not a subject of discussion. It would probably come eventually if it's not. But this is something to consider. Additive, now plasticizer, it's a substance that added to a material to make it softer or more flexible. It's the case for cables mainly. So they are added to polymers such as plastic and rubber to facilitate the handling of the raw material during manufacturing. Okay, it's also helping to create more easily the cable. In the case of a cable, we talk most of the time of phthalate ester, and also some lead are used to make to give some flexibility to the plastic. So it's yeah. Fillers. They are often added to polymers to lower their price. Okay, so people are trying to save some money. I guess there are some parts inside an equipment where it's not necessary to have like a very shiny look or beautiful flat surface. So this is a way also to reduce the weight of the equipment and to reduce the cost of production. So normally they are inorganic material, such as, you have a long list there: calcium carbonate, talc, silica, wollastonite, clay, calcium sulfate fibers, mica, glass beads, and alumina trihydrate. Voilà. Another additive, pigment, to give some colors. So plastic, generally, it's a resin that is almost colorless and milky white. So we can add some dyes to give it some colors. And cadmium pigment was used to give like the red color. So cadmium, it's a heavy metal, so we try also to remove that type of plastics. There are many types of pigment that can be used, but this is just for your information. And also stabilizer. The stabilizer will help some plastic exposed to the exterior to have a longer life facing like environmental effects, like UV light, heat, etc. So they also providing some protection against heat and mechanical degradation over the time. They're also known as antioxidant, antiozonant, antacid, biocid. Voilà. It's it seems that they're also helping the manufacturer to make them more easily for the production. Okay. We have announced a lot of facts since the beginning. At this step, maybe we can make like a kind of just summary. What is important to retain here? Because we don't need to retain all the things I've said, you know, it's information mainly about the types of additive we found. But what we can retain is that plastic are transformed material that may come in multiple form or of recipes due to additive that will give them special features. And we are facing a very complex mixture of many materials. And also, if you receive material that is dirty, it could be also an additional problem if you have like grease or soil or paint or pieces of metal attached to those pieces of plastic. It's an additional issue. We said that red color may be associated to the cadmium pigment, which is a heavy metal. Plastic generally in contact with source of heat may have been protected by addition of brominated fire retardant that may be potentially identified by your marking or not, depending of the if the people who produce it were very meticulous or not. BFR plastics need to be destroyed according to the Stockholm Convention when they meet the established threshold of destruction. We talk about 1000 ppm. Large plastic parts are marked, but can't always be trusted. Okay, so we have information, but sometimes we're not sure what to do with it. Is it true? So we need to have more knowledge of plastic types to recognize them, and let's look per type, what we could find inside the wheel. ABS, which is real name acrylonitrile butadiene styrene, and sometimes also mix of ABS and PC. This is the plastic that we use for Lego. Okay, so it's quite hard and it could be light, very lightweight as well. durable, and shock resistant. So this is something we can recognize of a Lego, okay, as well. Where do we found them mostly? We can see that vacuum cleaner housing. Quite often it's part of the outside bodies, mainly because to absorb the shock when you move them around the walls. We can think about large parts that need to support the shocks, some screen, and monitors housing that may contain BFR eventually. High impact polystyrene, we saw that it's a big part of the fridges, and also we can find them on keyboards. In general, if they are not in contact with heat, we can see that they are BFR free. Okay. But this is one that is quietly very, very used. Okay, Ppma, which is a real name, Polyoxymethylene. So this one is quite easy to recognize because if you play inside computers and PlayStation, this kind of stuff, when you open it, you will find a lot of these little gear system that needs to have very small slots. It's Ppma. It's the white plastic. I mean, it's not always indicated because of their shape. As you can see, it's not easy to write something on these, but it's written. So this one is quite easy to recognize in general. Polypropylene PP. It's a very flexible and soft material with a low melting point. When you try to cut it, it doesn't cut clean. And this example, this is the controller of my son. So there is a flap here. It's very flexible. You can open it. You see, you will open it many times. It will not break. It's made also to be flexible. So it's low density compared to other common plastics, and it's used often to be for hinge, for lids, flipping covers. Doesn't contain BFR in general. Polyethylene, LDPE, HDPE, use an application ranging from film, tubes, plastic part, laminate, insulation of wires and cable. Voila. Now, polyvinyl chloride, PVC. You can see it marked on your cables. The cables, it can be made softer and more flexible by adding plasticizer, the most used being phthalate. It may contain lead stabilizer like calcium, zinc, and can be used as well. It's not known to have BFR. How can we get those plastic removed from the metal? Because a lot of people will want to recover metal that has some value, like copper. I would say that burning cable, for me, it's a no-go. You don't want to burn that. It will release some toxic gas eventually to the environment. It's not necessary to burn that. If you have a system of a little shredder system, you can eventually shred them and separate the material, the plastic, from the copper. So I have put over there a little reference that you can click eventually. It will show you a very common system that is sold where you would put the cable inside and it will separate them into fraction. It's so mainly, and then you will get copper one side and the other side the plastic, little piece of plastic flakes. This material can be recycled as well. If you even apply an additional shredding step to the milling step to the plastic, you can get like a black powder of PVC, and this can be reused eventually to create other products. So there is an opportunity to do it. And you can make, as an example, maybe flooring mat, other pipes, this kind of stuff. Oops. Oh, what happened? Oh, I'm sorry, I hit the wrong button. I was not to show you the, but I think I've clicked the the presentation. Allez. Ah, merde. Ah. So as you can see, the system was um, I would say this machine is quite big. I've seen manufacturer or
So Mario, at least for me, I can't hear your speaking anymore. I think this is overwhelming your connection. But I can see some machinery where someone's throwing some cables into the system.
Yeah, okay. I will stop it there. This is generally, I think people saw it. We saw that they were recovering the copper and the plastic, man. Okay. So this is the thing. Going back to the from current slide. Et voilà. Voilà. Sorry about the blunder. Polycarbonate PC, transparent, strong, and rigid thermoplastic with excellent impact resistance. So you recognize here two elements where you can have this kind of polycarbonate. You can find it also on shavers or toothbrush equipment. Yeah. Another one quite easy to recognize is the Ppma. This is coming from a flat screen. It's also known as acrylic plexiglass. So most of the time when you dismantle a flat TV, you will find big pieces of these. And the good thing about it is if you recover a lot of them, you quite easily build a palette of this type of material and have good tonnage because you don't have to do anything with it. From my knowledge, I've seen recyclers, they were sending it like this, not shredded at all, this way. So they were sending it to other people able to manage it. Polyamide, also the same family of the nylon and Kevlar, is mostly known for wires and cords and tie wraps, but we can find some of them inside the as electrical connector, gears, etc. Epoxy resin. Now, this one is problematic because you may find inside it some brominated fire retardant, and because it is the base of the print circuit board, it's also creating a lot of issue because to reach it, it's not that easy. So mainly these plastics, they will end up in Europe and smelter, where they will be burnt and we will recover all the metals from the print circuit board. If we talk of country where there is no smelters, then where comes some issues is the fact that people will try to burn the print circuit board to get rid of the plastics and recover all the metal. And then when you do that, you will release toxic gas to the atmosphere and pollution. So this is something I would say again, it's a total no-go. Don't burn print circuit board because you will liberate some pups. If there is presence of copper and brominated fire retardant in the combustion process, it's possible to get some dioxin and furan, which are also nasty stuff that you don't want to bioaccumulate in the life cycle of your local environment. And also the other way of, instead, if you don't burn print circuit board, some people are using aqua regia, some acid baths, to try to decompose the material. And it's also very polluting, and not to say very dangerous to play with acid. has also some emission of gas that are very nocive, can occur eventually, like arsenic. This one's one of them. Conclusion about sorting. But before we go to sorting, I would say, we saw that some plastics have potentially toxic metals in them, such as cadmium, lead, and POPs. We want to divert these substances from the nature and keep them away from drinking water source to limit the impact to the environment. Okay. Most plastic can be recycled, which means potentially valuable material can be reclaimed, and there is a profitability that we will show you. There is a table somewhere with some cost pricing. Recycling plastic minimize the need to use virgin resource and protect the habitat, reduce carbon footprint for sure, and yeah, there is money to make. Potential profitability. I have put over there a link to a website where you can get some reports about the evolution of the cost of the material that you can reclaim from the recycling process. So you can see that the name of the chemistry of the material, like HPDE, PP, PS, PVC, etc. And the state of regrind or regranulates. I guess it's shredded and transformed in pellets. So you can see the evolution from September 2020 to October 2021. There is an evolution of the cost. There is a value associated to this type of plastic. As an example, if we take old fridges, which is, it's not 88, it's 80% IPS and 20% PP. So if we measure the quantity, the mass of those plastic inside the fridge, we can apply here the cost, eventually measure per ton how much money we can make. So this link is very useful because it can help you eventually build a business case to see if there is some money to make with it. Health and safety, environmental aspect. I will go quite fast about this because in the case of plastic, there is not so much issue. You know, you are a e-waste recycler. You operate your activity. I guess that locally you are already some rules to follow in regard of health and safety. But well, for sure, people they need PPE to protect themselves from eventually stuff in their eyes, to puncture their hands with something that is I don't know in English. Piquant. Sorry, I don't know how to say it in English. And also protect themselves from the noise, hearing protection, and a helmet in case something fallen on their head. So this is standard stuff, the PPE to be used. What we want to make sure if the burning of plastic should not be allowed due to the potential toxic emission. You don't want your employees to eventually work in the plant, try to sort stuff by burning material and sniff it, you know. This will create some long-term complication to them. So this has to be avoided. Handling plastic pieces with gloves is recommended, especially in cases where the load of plastic or we have been stored somewhere, maybe outside for a long period of time. And then you can have like some wild animals that will contaminate the loads with feces and urines that could lead eventually to some disease. You can imagine if people have maybe sometimes some issue with hygiene and then they get like contaminated with those contaminants, they can have some sickness like leptospirosis that may lead to some renal dysfunction. It could be an issue. Emergency situation management. I would say if you are a e-waste recycler, you have a lot of plastic on your side. One of the things you want to avoid for sure is a fire, because when the plastic will start to burn, it will generate dark fumes, and also create more problem for the community around your business. Okay, so it will fall down on the ground, contaminate the water source, the fields. You can have some issues for a long period of time. Mainly, you need to make sure that if you stock plastic in an area, you have also the firefighting equipment available to fight those potential fire event. Try to avoid to have some works performed in this area that could generate spark and eventually lead to a blaze. Implement a storage plan to enforce discipline across team, because you want to make sure that the plastic is in a good area, and don't put on around it stuff that could initiate a fire. As an example, lithium batteries, that could eventually be an issue. You should have a water fountain, water tanks with pumps eventually. You need also to be in contact with the fire brigade locally to explain to them what is the content of your inventory as a business. So if they come eventually for firefighting, at least they know what are the issues and where they should eventually fight the fire first. They know what are the priorities. Another issue, if there is a fire of plastic and a large blaze, the people will try to manage the event with a lot of water. Where the water will go after that? The water will be contaminated. So you need also to think about a way to make sure that that water stay on the facility and it will not go down the drain or the river, and where it will eventually kill all the fish of the river or the lake. So you have to manage to contain the water from the firefighting event. Yeah, it's a good thing to have the people of the fire brigade to see you. They can give you advice as well, and also they can help you to train some of your staff to be like the first aider on the event, to make sure to make the first intervention while the people are on their way to help you fight the event. So that's some of the things you need to think about. It's something general to many business. I would say it's not only for e-waste recycler, it's any type of business. Collection, handling, and storage. So yeah, you should. I said that you should determine a storage plant eventually to avoid mixing stuff, waste type with other type of waste. It's easier to recover and manage. You will gain some time. Avoid direct storage over the soil that could lead to dirt buildup inside the plastic that you want eventually to recycle. There are some studies that say that BFR plastics over time, they will degrade if they stay there too much time, and with the rain, you could have some kind of leaching occurring and some losses of contamination. So we try to avoid to have this directly on the ground. It's also known that if you keep material long-term storage under the sunlight, it will degrade the polymeric chain. One of the examples, if you have polyurethane foam, if you keep it under the sun for many years, after some years, you will have like it would be full of hole like a cheese. So it's degrading quite rapidly. I would say that if you, I would recommend to have it stored inside to avoid any contamination, or at least covered to keep it clean for your further processing. So this is like for the storage and handling on the side. The next step is really the effective sorting on the facility. Daniel, do you want to make a pause now, or?
Yeah, I think this would probably be a good point to just stop and pick up any questions we might have from the participants, and then maybe we can move forward, depending on time, also have a quick break. So thanks, Mario, very much for giving us the overview.
The next big chunk, is sorting, and after that, it's the next big chunk is going to be recycling and elimination disposal. So yeah, it's a good time to make a break or have questions. Yeah.
Perfect. So yeah, I've been following the chat, and Arthur's been very kind to jump in and answer some of the technical questions there. So there was a question on the costs of or the profit you could make from different types of plastics. I think you've just covered that. There were also some other links from Arthur coming in there. Arthur also had a important precision regarding the brominated flame retardants. I don't know if you want to just kind of jump in and I just see if I can unmute you, Arthur. Don't seem to be able to. Just try. Yeah, if you want to ask or just state that comment yourself, you're welcome to unmute yourself and just explain a bit.
Yeah. Hi, can you hear me?
Yes.
Great. Yeah, I just wanted to make a clarification that I mean, when we talk about BFRs, we talk about like 100 different like substances which are commercially available, and yeah, only a few of them are actually POP, have been classified as POP substances, and that have to be destroyed. So and over time, as some BFRs became POP, they were phased out. So that over time, actually, the share of these POP BFRs that you find in the waste is decreasing.
Yeah.
And right now, based on up-to-date data for Europe, like the share of these POP BFRs in the whole like BFR quantities is about 10%, and it's it's always getting lower. But the thing is, as a recycler, you cannot, like in a day-to-day setting, if you get a plastic piece, you don't know if it's containing DKBDE or like another BFR which is not restricted. The best you can know is whether it contains bromine or not. Yeah, you can use like X-ray machinery to detect presence of bromine. So you can see, oh, there is bromine, so maybe it is a restricted POP BFR, but most likely it is not. And that's why you have this threshold of 2000 ppm of bromine, which is like a safe limit. But basically, like it's a very complicated story, but it's more complex than just saying BFRs are bad and all BFRs have to be destroyed. Like legally, it's not the case, because you have this like low and decreasing share, which is actually POP and hazardous.
I totally agree. Yeah, true. Maybe I've been too much dramatic about the case of BFR.
I mean, you have to simplify things. That's of course that's normal, because everything is very complicated in that field. And again, like practically, that's what is being done. Is like, if there is a risk that it contains these substances, then you better be precautionary and treat it as if it was containing these POP substances. But the reality is that it's less like you actually, if you just get now, if you go to a European recycler and take a sample of plastics, most of the time you will actually not even detect these POP BFRs, like they will be below the detection limit, and that's like over year that becomes more and more common.
Yeah,
and that's good news. It means that the regulations actually worked. And again, if you go to more like lower income countries where appliances are older, you will find these POP BFRs in much higher concentrations still.
Yeah. Totally agree. You know, we work with a lot of recyclers, and this year, when we make audits, these people, they are making tests, taking samples, and most of the time, it's not detectable on small domestic appliance, you know, plastics. And CRT TVs, there is less and less collected. So in a sense, it's disappearing as a problem, as an issue. But yeah, true. you know, it's a very complex topic and we have to make some shortcuts, but it was not my intent to give a bad talk about all the plastic manufacturer who incorporate this kind of material. Some of them are good for sure. Yeah.
Mm.
So I'm sorry, sir, you're from which type of enterprise, business or field?
So I'm working for Sophies, which is a consultancy company. I'm based in Switzerland.
Okay.
And before, like I've been there for 2 years, and we implement projects related to e-waste management and plastic waste management in different settings. And before that, I was working at Ppma, also in Switzerland, and that's when I started, like maybe 5-6 years ago, to really focus on e-waste plastics and looking at the data, looking at the composition, looking at the management options in both in Europe and also in developing countries. I was like 6 months in India, kind of investigating what happens to these plastics there in the informal sector. So I'm quite passionate about this topic. So I'm really happy to be able to join you guys today.
Thank you very much. Thanks for your help.
Yeah, we're also very happy to have you with us, Alpha. I think we already saw 2 of your diagrams, which Mario was sharing from the study, which you were the lead author on. And I think we'll have some more of your diagrams coming from Ppma as we go forward. So it's great to have you there, some of the additional experience.
Yeah, nice.
So Mario, we have one more question, which is asking, well, what should we do if we don't know or can't trust the label on the back of the plastics? And I think that's the perfect question to lead us into the next section. But before we do, I mean, we have now 2:10. We want to build a 5-minute break into the training so that you're not all overwhelmed by screen time. We can either do it now, Mario, or we can do it in about 20 minutes. What would you prefer?
Maybe now. 5
Yeah.
minutes. Okay.
So we just take a quick 5-minute break. We'll be back at 2:16 in German time. So it's just be 5 minutes. So you're welcome to just take a quick toilet break, grab a coffee, and we'll be restarting on how we could sort and what kind of techniques could be used there in 5 minutes. Thanks, everyone.
Thank you.
So to bring us back, I might actually just share the results of our survey, which we forgot to share at the beginning. We only had 13 responses so far, so it's not a full picture. We'd like to add a response. Just share the link again. But I don't think we need to spend too much time on it, just to give you an idea who's with us today. So I will share my screen. If that's okay with you, Mario?
Yes.
So here we can see the 13 answers, and I know this is not a full overview because I've seen at least 3 people from Latin America in the session with us today. But you see we have a few members from Africa, from Europe, 6. So from Asia we've got a number, and Eastern Europe. So actually I think we've covered the whole world. And I know shout outs to WeCenter, who said that they're joining with one computer with 10 people watching. So we definitely have a lot of people from across the world. What is your experience on managing e-waste plastics? Well, so far from these 13 answers, we have about 45 people on the call. So this is a very small snapshot. Looks like about 45% haven't got much experience with managing plastics. Some, maybe a third, let's say, have started some operations, but need some more support in optimizing this, finding solutions. The green one is so operations in place, looking to optimize. Yeah, so sorry, the orange one was some operations in place, but not sure what the best approach is. So it's about a third. The green was have operations in place, but looking to optimize. And the red one, I consider myself a plastics expert, e-waste plastics expert. Another answer gone in there from Latin America. Do you have solutions for your plastics? No, not sure. Yes, but inadequate is the orange one. I think that more or less covers the answers here. It was a bit unnecessary to have too many different plastic types. And what are your biggest challenges relating to managing e-waste plastics? Well, we see here proper collection and sorting and consumer behavior, aftermarket for recycled plastics, financially sustainable collaboration with the informal sector, identification of different plastics, giving them sufficient value to make them interesting to recycle. It is quite new. BFR plastics, reaching the desired recycled quality, separating plastics with and without additives, unavailability of relevant info or database on the amount of e-waste plastic collection and recycling, lack of downstream outlets for both valuable recyclables and non-recyclable fractions. There is no clear practice yet in my country, or once plastics are segregated, which is expensive, finding a market for that is complicated due to the small volumes. So a lot of interesting challenges, I think, facing different recyclers there. This is just a snapshot of who we have with us today. I think it's actually a very diverse group, and I'm really happy that we have so many of you with us today for this training. With that, I will stop sharing my screen and hand back to you, Mario.
Yeah. From current slide. Okay, so we start again. So as a e-waste recycler, you may ask yourself, if you're starting in this business, what should I sort for recycling? So eventually, if you're an e-waste recycler, you will remove probably the plastic from the put it in a corner somewhere. Eventually, you're going to have a big mix of plastic from different type of equipment. Which type of plastic should I sort? So it depends. Also, if you have in your area some people able to transform it, to do something with it. There are the people that we call the compounders that will transform the plastic in a format ready for the molding machine of the manufacturer that will eventually, or maybe subcontractors of the manufacturers that would transform the material and the piece that could be used inside another equipment, or it could be also a common product from their life, because the plastic may be used eventually to create something else that is not electric or electronic equipment. Okay, so you need to know who's available in your area to deal with those plastics. What are their needs? Do they have like specification? Do they have projects to implement under material some recycled fraction? So what are their priorities? Is there a collection network that could be organized or already organized to bring that material to compounders and for producers? You need to study the market for pricing. So we gave you already a little indication. I'm sure it's not the only page where you can get this type of information. There is probably something in your area as well, in your local language, that you can find. What are the alternative use for plastics if we cannot send it to a compounder eventually? So we talk about profitability. And also, if you get in this type of business of transforming or sorting plastic, make sure that you have all the required permits, to handle this type of activity. So those are some type of questions you need to ask yourself. Also, if you go in that business, you will need to check many factors to make sure that you have enough room to stock the material. Also, determine what you can recover from a different source. Do you have the labor, the energy? What is the energy cost associated to this business? Investment capacity that you have. Will you have some money to purchase some tools? Or some machinery eventually. We already talked about the specification of the compounder, very important. And also verify what is the level of contamination of the material that you're collecting. For sure, if it's contaminated with oil or grease or other, you would probably have also to implement some steps of washing the material. There are some possibilities to sort the material and stock it as in bulk parts, like and bale eventually, that you can send maybe to other companies that have equipment to shred it to make smaller flakes or a fraction of it, or you can also shred it to make flakes. In Europe, there is a trend to have most of the wee plastic transformed in flakes and sent to third parties, which has process to separate the plastics. The sink float process is, there are many companies now installed in Europe that are able to manage this. So with the help of density process with salt solution of different value, you will be able to separate different type of plastics. I guess the fact that the BFR issue came and the scope of the business in the recent years, people thought it was complicated to determine which BFR plastic was good, which one was bad. So the solution was really to send it to somebody that is able to manage it. They say some people also, they are sending the material bale, on pallets, big bags or whatever, film to other processors. So there is both of this mix of process.
So Mario, just one question.
Yes.
So we saw, I mean, half the participants haven't got so much experience with managing these plastics. So could you describe what baling means? And I'd like to also say to the participants, as we go forward, if there are any terms that we're using that are for you confusing, you don't know what it means, don't hesitate to ask the question. That's why we're here. It's a training. So we might have jumped over some of the definitions. So please just ask the question if you need to. But Mario, back to you, baling.
Yeah, a baler is a system to compact. It's a kind of metallic system, a box where you will put large part of plastics, and you will apply a huge pressure to reduce the size of it, to compress it, to make a bale that will take less volume to be carried around. I have an example of bales somewhere. I remember they were like, if I remember well, you see, this is like some bale. I don't know if you see the screen now because of the lag of the screen, but this has been compressed. You see it?
That. Yeah.
Okay.
Perfect.
That's
Thank you.
You see, it's attached. It's attached with cables as well. Well. So manual process. What you can do manual dismantling with visual classification based on knowledge of the appearance of the type of material you see, and the marking of the material is probably the fast way to do it. I said, there are some material, it's quite easy to see if it's POM, if it's ABS, because are some markings. You can maybe do like a first type of first sorting process to separate the categories, but also not just based on marking, because we said that there are some issues with the marking sometimes. There are some other tests that can be applied by dismantler. Some years ago, Ppma, which is Ppma is an institute of a scientific institute of Switzerland. They have made a study for Prevent, and they issued a good process that could be used for e-waste recycler with limited infrastructure, to put in place a sorting process. I call it the Ppma classification methodology because this is their baby, So this is something we will go through in the next slide eventually. The main idea is that every type of plastic, okay, we saw that there is an appearance that can give you an idea of what is the type of plastics. There are some markings, but there are also some kind of physical properties that can be used to give us confidence that I have done quite a very good sorting process, okay? Some of the steps proposed by Ppma, for sure, it's maybe complicated to put this as like a continuous process. When I talk about continuous process, you put a load of waste in the process, it go through many steps, and it go through the steps, like almost automatically. With the Ppma classification methodology, a lot of things, it's more like batch tests you can do for verification of certain load of plastic for which you're not sure about if it's totally this type of plastic or not. So we will take a look at it. One of my recommendations also is try to work on a lot of similar type of waste. If you work, let's say, on a load, a lot of vacuum cleaners, because you are getting a lot of vacuum cleaners, then you can generate some ABS and maybe some PP pipes that you can put aside. You will create rapidly some sorted loads with value. Or if you manage a lot of computers rapidly, you can see a lot of POM, little gears, this kind of stuff. It's easy to generate rapidly some good loads of already sorted material. Yeah, this is what I call the quick wins, mainly. If you do a lot of flat TV, Ppma, then rapidly you can build some pallets of it, or the CRT plastic housing that may contain BFR, Also, if you manage cables or polyethylene with PVC, polyethylene, you can strip them and you create rapidly a load of sorted material. So the quick win is really to spot the things, the type of equipment, and work on this type for a certain period of time, and then you generate sort material. Yes, you can do manual process to try to take a look at equipment and try to figure out with markings or what they are really. There are also some tools that exist to detect the presence of contamination. I have put over there 2 links to some equipment that are not given, that are using some spectroscopy methodology to analyze the equipment and see what is the type of contamination you may have inside. What is the nature of the plastic? We are looking if there is bromine mainly. So those equipment, they are around 3,000 to 5,000 euro. Yeah, it's not given, but I know that there are also some other equipment more expensive. Are they reliable? I never tested myself. Some feedback I got from the recyclers is that they are expensive. They don't always use it. You know, at the moment, finally, it was more easier to send the plastic fraction to a company able to make sorting by density, sink float process. So, yeah, it's so there is another way to do this. You don't really have to use this type of fancy equipment. Just a minute. This is bothering me. Oh, well. I'm talking again about the BFR plastics and the one that we need to remove. Yes, with these equipment, you can detect bromine for sure, but there is also ways to verify if there is presence of this contaminant inside the plastic. So we can eventually verify on specific type of equipment if there is a presence, knowing that there is a high probability to find it. I already talked about the monitor housing, the power supply, the optical readers. This is also if there is a marking FR, assuming it is. But we said it's not always accurate. So there is maybe other way to find it. So you can make some laboratory analysis of this. So there are some methodology that use with chromatography. In Europe, what we ask our suppliers, they need to take samples of the plastic coming out from their process, and they send it to laboratory, and they will be analyzed in function of the POPs that are listed previously in the previous page, the one that we are targeting. So we will get like a result based on the total POPs present. One of the issue about this method, especially in a faraway country where maybe you don't have a laboratory, it's maybe complicated maybe to have a lab to do it, knowing there is a methodology. One other issue I would say with this type of processing is the sampling process is very important, how it's applied, because if it's not done properly, you may have results that are kind of irrelevant. So you need to make sure that you are taking like a part of what is generated as a certain frequency and build up a sample, and at the end of a certain period, you mix those samples and you make another separation to get at the end like one mixed small sample that you can send to the laboratory. So there is a methodology associated to this that need to be used. Now, it's complicated, I have to say. So maybe we can go to something more easier. And I guess this is what we call the sorting alternative that the people from Ppma generated as ideas some years ago for Prevent, which are some common sense things based on scientific facts that are reasonable and also very low cost, I have to say. Some plastic have a level of flexibility, and when they break eventually, they will emit a noise. So building your own experience, knowing this is like PP, PE, or ABS, or PC, by breaking them, you will hear a sound, and at the moment you can determine this is this type of plastic. Yeah, so this is probably something that can be done. Probably not like the first choice which we should have today. There are some other good idea. There is also the sound when you hit them. So maybe there is some kind of resonance when you hit them. Is there like a noise coming? This is a way also to figure out which type of plastic we are facing. The density, this is one of the subject of today's presentation that will be highly visited check, because this is something that is also used industrially by many companies in Europe. So you can have a system of many tanks in series with in each tank a specific density. Each density will allow you to separate some type of plastics from others, because mainly all the plastics that exist, they have different densities. And that's a good opportunity for us to make like rapidly bulk separation of different type of material. When you apply some logical rule about the densities that you will use for this process. Okay. It will be the presentation on the next slide, you will see. And also there are some reaction with solvent that will happen. Ppma some years ago proposed acetone and limonene. Limonene is a kind of essential oil coming from the peeling of a lemon. Okay, so if you use that oil, that liquid, and you put it on the surface of a PS, it will become sticky. So there is a kind of reaction occurring. With acetone, it will be on ABS and PS that something will happen. It will degrade, and you will feel that it's sticky. You see, so those are some kind of chemical property that can be used for the selection of material. I've seen on the website somewhere, maybe I should have put the link. There were some others possibilities that you could be used. So if you have some willingness to dig the subject, there are maybe some opportunities also that we can evaluate. I've seen some with oil, but maybe if you add oil to plastic, it would create more problem eventually for the hand processor of plastics. But yeah, there is maybe some other opportunities to check. And finally, yeah, you can burn it and smell what it smells. So the other will tell you which type of plastic you have, but we don't do it, please. We forget about this because you will get your employees sick. So we don't want to do that, for sure. It's another no-go for today. Sorting by density. I have put here at the bottom of the page a link to a site where you will get densities of plastics. There are many types of plastics, and often it's the same chemistry, but with many different type of percentage of fillers or additive. So the density will vary a lot, based on what you have as additive. But it will give you a good overview of what is possible as densities. Okay. The other table on the right is if you want to create for yourself a tank with a specific density with salt, you have over there the indication of how much salt you need to put inside the tank to generate your special density liquid. Okay. So mainly, what we recommend is the use of salt, because it's quite handy. You can find salt everywhere. I know that there are some other type of salt that can be used, material, but I recommend this one because it's probably the easier to find. Here, a little table also derived from some information I found about Ppma. So you see on the bottom of the screen, you have many types of plastics. Okay, and then there you have three lines: the red, the blue, and the green. So the green line is pure water. The blue line is a solution of water and salt with at a density of 1.1, okay, and with 160 grams per liter of salt. And the red line is density of 1.2 with 360 grams of salt per liter. So what does that mean, this graphic? It explains that the density of PP and HDPE, at the bottom left of the graph, they are less heavy than the water, which means they will float. Okay. If you take a look at IPS and PP20, they are located between 1 and 1.1. Okay, so it means that in a tank with pure water, they will be heavier, so they will go down the tank. But if they were in a solution of 1.1 with a density of 1.1, they will be below and they will float on the tank. So mainly you should see it on the reverse, this graphic. What is on the bottom will float, and what is on the top will go down the tank. So mainly. As an example, if we go on the far right, BFR plastic, polyethylene, Ppma, and PVC, they are quite heavy compared to the solution that has on the red line at 1.2. So that means they will go down the tank. So by organizing the tanks that you have with those solutions, you can eventually organize a classification of material based on density. So starting from the right to the left, you will get the lighter to the heavier, and you just need to adjust the density of the material. I don't know if I am clear. It's clear to me, but maybe I have difficulty to explain it.
I think
Yes.
it's okay.
You have a question, Nadia?
No, I just want to say I think it's clear, but it will become clearer with some more visual in a moment.
Yeah. So density fraction plastic group. So on the previous graph, on the previous graph here, these are densities that were suggested by the Ppma group. Okay. It's interesting because I took a look at those densities and also took a look at other studies. There is many things said about the type of the density you should use, but yeah, various densities can be shown for each type of plastic polymer, so it depends on the presence of additive or not. So that's important to take a look at. And in this case here, if you hear about like halogenated ABS or non-halogenated, we talk about brominated fire retardants. Okay. And now, the nice graph by Ppma regarding the process proposed for e-waste recyclers. So there are some tests that can be done, and we will follow the graph. We talk about noise and breaking of material before. There is also the cut test that can be done for some surface. One of the first tests you can do on a plastic, if you use a cutter and you cut, as an example, a PET bottle like PET, which is a thermoplastic, you will see that you will get like a smooth and a clean cut. But if you do the same cut on a bowling ball, then you will see that what will happen, the cut will generate some kind of little fibers. It's not so clean, it's irregular. So it may lead to creation of a little channel on the cut with material accumulating. That's the difference. So the cut test can help you at the moment to determine what is thermoset and what is thermoplastic, which are fully recyclable. And after that, if we follow the graph, we have thermoplastic there. We do tests with limonene, the citrus oil. So if you put it on your piece of plastic and there is a sticky reaction, there is a high probability that it's going to be high impact polystyrene. Okay. If not, there is no reaction, then we have to apply another test. But let's go back to the IPS. We said, okay, this is high impact polystyrene, as an example, plastic from the fridge. So if we put it in a salt solution, if it's floating, then normally it means that there is no brominated fire retardant inside it, okay? But if there is BFR, it will sink, because that's one of the particularity of the this kind of additive. There is an addition of weight associated to it. It's heavier at the level of density. So this is the way, this is what we will use to separate some type of material like ABS as well. We will see that there are ABS without and with retardant. It will, because there is the difference of density. So in this case here, we see that we have separate two types of IPS, floating, sinking. Sinking, this one needs to be discarded, okay? If we go to the next step, we had a piece of plastic, we use acetone, there is a sticky reaction, again, probably ABS. Salt solution with a density of 1.2 this time. BFR is going down the tank, and the one without BFR will float. If you permit me 1 second, I will go back 2 slides. You see ABS here is we talk a density of 1.2, BFR plastic, ABS with BFR, I'm sorry, there is ABS is missing here, so it's there, and ABS without BFR. So this one will float, this one will sink. So it's really in correlation with this graphic here. If it leaves a white mark, the little acetone, where you can find acetone, it's mainly the product to dissolve the nail polish. Okay, so that's easy to find as well. Okay, so if it leaves a white mark, probably PC or PCABS. If there is no reaction to acetone, then we have like a big bunch of possible material there: PP, PET, PVC, polyamide, polyethylene, other. Then we have to operate with our water test at a density of 1. We saw that PP and PE, they are very low density, so they will float for sure at 1. So over there, you can make a stretch test. You can make a cut. And then if there is a mark, it's polyethylene. If there is no mark, it's PP. And if it's sinking, then you got like those possibilities there where eventually you need to apply more sorting. And I guess you can eventually apply some more tanks if you want to make a separation. But you need to evaluate also if it's worthy to do it. What would be, you need to evaluate what is the volume of this type of material. What can I extract with a value from this? So, but yeah, there is a potential here to add more steps in the future for the sorting. Before I go further, any questions or? I have to say it's ingenious. It's
So there's a question from Siddharth. I need to unmute you, sorry. Moment. So Siddharth, you're unmutable now. If you want to unmute yourself and ask the question.
Hi, thanks Mario for the great presentation. The flow chart is really nice to understand how the BFR plastics are being separated. Also, the contribution from participants helped me understand that. My question is, in one of the pie charts before, you showed that currently there's around 2% BFR HIPS and 3% BFR ABS. and the sorting process in the flowchart, is that actually being followed for this 2% BFR or 3% BFR, or does this end up as a contamination with ABS and HIPS, which is without BFR?
I don't understand the question. Sorry.
Sure. Okay, I'll repeat it. So there is 2% BFR of HIPS, let's say, and 3% BFR of ABS in the whole e-waste plastics.
Okay.
Is this actually being sorted at the moment, or does it end up as a contamination?
In Europe?
In Europe, if the flowchart represents Europe.
Yes, and the facility where huge amount of plastic are sent for to be processed with sink flow process, there is a portion of the BFR plastic that is removed through this kind of process. Yes.
Okay, thank you.
Yeah, there are some companies like MBA Polymer, GV Evergreen, Gallo in France. They have this type of process, and also in the UK there are some other companies involved with this. So they can. There is not only a sink flow process. There are other ways as well to separate the plastic by some type of fancy machinery. But for today, we are using this methodology where it can be easily reproduced. You know, a tank with a salty solution where you can drop material, where you will have some material floating, some will go down the tank. You recover what is at the top. You transfer it to another tank eventually, where you will have another density, and at the end you will be able to separate some material. I've seen some guys in the UK, big facilities with huge machinery at the moment, make a lot of tests with metal skips, big container to recover metals. They were putting valve on it, putting water, making tests. It's possible to do something low cost eventually that could work for sure. Yeah, you have to put the effort to design it, and
perfect. Thank you so much.
Maybe the gentleman that talked previously from Ppma, who has done some work in other countries about this, have some idea as well.
Yeah, happy to jump in. Yeah, so actually, when I was at Ppma, I was together with my colleague, we developed this flowchart, and actually that was based on largely based on actual observations from informal wee plastic sorters in India, who were applying many of these techniques to do this manual sorting, and that was a great inspiration for us, because in Europe, like everything is done mechanically with mechanical and automatic sorting machines and equipment. Which have many strengths, like you can have a much higher throughput, and with high labor costs in Europe, it's just makes sense to have this machinery. But somehow with hands and nose and eyes, you can operate a finer sorting. So we saw great potential for these simple techniques, for which you don't need any investment to be maybe useful for other countries with relatively cheap labor. And also, I mean, we developed that as a training tool. Like, we organized training events with different stakeholders in many different countries, and that's like it was a fun way to get hands dirty and start to understand like what are the differences between different plastics and how we can separate them. And yeah, I mean, the first time you do it, it takes time to do each test. But if basically that becomes your job and you do that every day, after a while, you don't need to do all these tests, or you just do it if you're unsure, if you have doubt. But after a while, you just develop this kind of almost natural feeling or instinct to differentiate between different polymer types. And yeah, the density thing, it is still widely applied also in Europe, but again, not like with huge tanks, not like large scale. And yeah, as Mario was saying, actually density separation is not only applied for plastics, but you also have facilities which apply density separation to separate different non-ferrous metals. So it's actually quite powerful as a simple physical mechanism to sort different materials.
Hi, Arthur. Just to be clear on one point, so you mentioned that Ppma made this flowchart based on the observations in India, if I understand that correctly, and the same concept applies also in Europe.
Well, actually, I was in India 6 months, and I was in Delhi, you know, in different neighborhoods, and just witnessing and interviewing these informal waste sorters, and yeah, that was a big inspiration to then develop this flowchart. It's not only based on that; it's based also on other sources and trial and error also at Ppma. But in Europe, no one is doing that, following this flowchart at industrial scale, you know, because there are all of these separation processes automated. You have different techniques, you know, electrostatic separation, infrared separation. So it's all done mechanically and not manually in Europe. But I mean, the result is the same. You have, you know, ABS and HIPs without BFRs, which are separated. Same for PE and PP and PCABS. So the result is the same, but yeah, just one is labor intensive and the other one is just machinery intensive.
So thanks for that, Arthur, and also for your efforts to make this diagram, which I think is very useful. There's a question in the chat for you, Mario, or I guess as well Arthur, but what size should the plastics be shredded in order to prevent any buoyancy effects from altering the separation? So I think this is a question about being careful not to shred too small.
Yeah.
And then the second question was, do you need to wash the plastics after you're using the salt solution? Is there any kind of contamination that could come from putting it in the salt?
I would say that if you make flakes, it would make sense to make around between 10 to 20 millimeters size, something like that. It seems to me this is what I have seen for the industry in Europe.
Mm-hmm.
So I don't know if my colleague from Ppma is happy with that as well, or but and also to if you know if your material is very dirty or because it was full of dirt, I guess somewhere in the process you need to wash a little bit to. It depends what you're getting. So.
Mm-hmm. Yeah, I agree. I think it probably around 10 to 20 millimeters is it's a good balance, but it really depends on what you want to do afterwards, like what kind of further sorting and separation techniques you want to apply. Yeah, the same with the contamination. Like if you have residual salt, like NaCl, that will really mess up any electrostatic separation that you may want to apply downstream. So you definitely have to wash it and dry it. But yeah, this may not be necessary for other sorting techniques downstream.
And one of the points about those tanks, maybe not covered today, is I guess with time, I don't know if the density stay. You probably need to control the density to make sure it's always at the right level. So yeah. If you're using on the next, a very long period, you need maybe to make some checks to make sure it's still valid, make some controls.
Great. So I think that's most of the questions for now. Mario, are we going to see something in action? What this could look like?
Yeah, I have some of my colleague of ERP Portugal that have prepared some video, not to show directly the sorting process as we have seen on the graphic, but it's much more related to the physical property of the plastic when we talk about density, acetone, and limonene. So we have 3 small movies. Don't be surprised, it's in Brazilian and also in English, the subtitles, with a very loud music. So maybe I will not be able to talk because you will not hear me. We hear a lot of music. But so we will pass the 3 little movie. They are quite short, okay, and it will give you some indication about what those physical property can do for you, those reaction can do for you.
And we'll try it on your connection to start with, Mario. But if it's a bit slow, then we have Anita as backup to share her screen.
Okay, Toro. Yeah, thank you, Anita. My angel.
So I think you can actually talk. We can't hit the music. So talk over the top, Mario. Maybe Mario hears music.
Ah, so
and
you
we don't hear
see,
music.
no, it's because I have stopped the music.
Okay, yeah. So we don't hear any music. We have silence, but now we can see it seems to be playing fine. So go ahead.
Okay. Oh, I'm sorry. No, I'm sorry. It's the first time I play with video like this. We started. So this is a chart that we saw already, explaining the concentration. What can be done with water in the tank, salt, based on the concentration. So now we have 3 tanks with 1 different density. Plastics. So in this case, it's the same plastic.
Yeah, and we can't really understand what you're saying, Mario. But we can see the video.
Okay. You don't hear me. Perfect.
I think it's overwhelming your connection. But I can probably my connection is not overwhelmed. So here you see the different tanks at different densities and what happens if you put different plastics in there. So we've just seen HDPE was floating. Doesn't matter what density it is, water, salt, or more salt. PET was on the right of that graph, so it's quite high density. And here you see that it's sinking in all 3. And again, with some red PET, just to kind of show a bit the difference between the different density tanks. You can see here it's sinking. That's what you'd expect as well for your BFR plastics to sink in the different solutions. ABS is the one where Siddharth was asking questions. Shouldn't this be somewhere else? Where you see in distilled water it sinks, but put a density of 1.1 there and it will actually float. But if it's containing also the brominated flame retardants, then you'd expect this to sink as well in the salt solution. So that's how you then separate between the ABS, which has got BFR and not got BFR. So that's just to give an idea of how these density tanks are working. And here's the reaction to acetone. So there you can see it's becoming sticky. ABS has been put acetone on it. You can also apply it to ABS flakes, where they then become sticky afterwards. So if you're putting it as well on PC or ABS, you get a white mark. So that's just to kind of give you an idea of how that looks like. Mario, I don't know if you heard anything from me with all of the music on your side. But here's the last reaction. So this is with limonene. This is using polystyrene, so PS glass, just to kind of show you what this looks like. You put some limonene on it. It's difficult to see there, but it becomes sticky when you put that there. You can also test this with your finger, that it will be a bit sticking to it. So that's just a bit how you can apply those tests. And Mario, I've done a bit of narrating for you, but I give you the floor again.
Thank you. Yeah, maybe we need to get the volume of the music lower for next presentation. Okay, starting density. So we saw with the graph of Ppma, at the end we have a load of material where we have to sort, and also we saw that we got some load of material that may contain BFR. So we are able to create high density fraction that contain a complex mixture of heavy plastic and with various additives. Okay. For sure, the fraction contains more than 95% of the original brominated fire retardant content, since density qualification is very effective to separate bromine fraction. Okay. One thing we ask to our suppliers in Europe in general is to make sure that the load of material that may contain brominated fire retardant is not sold to enterprise that will recycle them to create some kind of food container and plastic food toys for the kids, you know, because there is always the risk that if it goes to some places where they would manufacture it whatever they want with whatever they found, they will create some future problems for the population. So that's important to make sure that we found a safe elimination of this type of material. So now let's talk more about some industrial process. So mechanical process. So the plastic that you recover can be washed. We can reduce the size to a dimension that will create some good flakes that will be analyzed in further processes. You may have a magnet somewhere to remove screw and nails that are stuck in the loads or attached to some plastic parts. So this may need to be sent to another shredding process eventually to separate it. But industrial process, through the use of different technology, it's possible to make some good loads of material by using other properties like density, electrostatic separation, magnets, okay, and also NIR separation process, which are kind of a reflectance system where you would put some lights on the plastic pieces and you will detect some special effects. You would measure some you would measure some kind of reflectance mainly, and it will help you determine which type of plastic it is. Okay, we will take a look at some technology. But it's possible to separate at a high level of purity. This is what I was talking about, the NIR, near infrared reflectance spectroscopy. So we know that different type of plastics, they will react to some lights at different wavelength. So they will generate a reflectance. So knowing the reflectance of a type of plastic at a certain wavelength, we are able to detect here on the machinery at the end of the conveyor which one is PET, HDPE, PVC, PS, and the system with some air nozzle with signals. We have identified a piece of material, maybe here it's easier to a piece of material that contains PVC, then the air nozzle will push the PVC pieces on another conveyor, another box somewhere, it will be separated. So we can separate this way. This is like the fancy system that I said are used by the industrial companies. You can this way separate different type of plastics by this technology. Okay. It's also used this type of system not with infrared technology, but other type of X-ray for the separation of plastic with lead. No, excuse me, glass with lead and glass without lead. When you do this, the treatment of the CRT glass from a TV, this is a similar system you can use eventually to separate the fraction. Industrial sorting system, best available technology. This is maybe at the moment what is seen as a high potential process, because you see we have some bubbles here. It's coming from this presentation of the Bolo, if you want to take a look at it. So the wee recycler will receive material and wee plastic, will separate them. This is inserted inside the density separation process, like we have seen. So you will separate all the type of fraction by density. The AV fraction will go this way. And some other fraction that may contain BFR but still can be recovered, like because we want to recover PS, ABS, PC, ABS. They were going in this kind of process called Creasol that has been developed by the Fraunhofer Institute, where they use a process with many types of solvent to extract the contamination of bromine. So mainly it's helping to depollute what contains some kind of pollution, and then you generate more plastic for recycling. So this is what is we consider well advanced technology. Now, management of the classified fraction. When we talk about a baler, you have a baler here. Okay, this one is for cardboard, but it's the same system. So when you have classified your fraction, they are well separated, they are well identified, then you have to keep clean. You have to keep them clean, away from dust, because this is a plastic supply for your customers eventually. Keep it away from heat source, spark, and lithium batteries to avoid fires. Keep it away from contamination. For sure, you have a clean product, you have invest a lot of time to sort it and clean it. It's not time to contaminate it with oil, solvent, and chemicals. Also important to use clean containers. I have seen in Europe some recyclers separating fraction from wee, and they were putting the wee fraction in containers that contain some asphalt and bitumen, greasy stuff. It's contaminating the material. It makes no sense. So please don't do that. So you can reduce the volume also of your material if using baler or a crusher, depending of the size of your plastic fraction that you have collected. Okay, because you could have decide at the moment. As an example, the Ppma material, the white plastic, the small gears. Maybe you have decided yourself, I will put them on a container somewhere. For me, it's Ppma. It's written on it. So maybe you want maybe to crush them, make some flakes with it, or depends of the need of your compounder at the other end. Maybe they have their own machinery and they will do their stuff with it. So it has to be seen. For plastic, big bags are commonly used to carry the material that you have generated. So it's also easy to use when you think about the after management of the container. When the compounder receive it, maybe he can after that also keep them for you, or he will discard them. Some things to think about. And also keep your loads of material away from collision path to prevent bags from being punctured and have other material falling in the street, or so to protect your asset mainly. Recycling, we know that recycling with plastic, it's quite a challenge to turn this in a high value product. So we know that plastic separation and purification, it's not that easy. It can be done and achieved, but you need to have the technology to separate it and shred it. There are some removal of non-plastic contaminant to be think about. Sometimes you have piece of plastic with some rubber seals. If it's not coming out by itself, you need to think to remove it. Recycling, you may have from your compounder or manufacturer that wants to have material. They have some very demanding mechanical properties requirement to respect. Cleanliness as well is important, the quality of the material. So this is all things you need to consider. You need to consider the presence of legacy heavy metal and flames retardants when it's present and when it's hazardous. So, and also, yeah, it's important, I believe, as well to clean the plastic that you are collecting. If you receive plastic from an e-waste shredder and your job is to make some sorting of it, when it has been shredded, the e-waste, there is always a possibility of contamination by metal of your plastic, the presence of cadmium or lead or this kind of stuff. So the washing process will be important to remove some of this type of impurities. And evidently, if you wash, think about the water management aspect of this bath that has been used, how you will handle this water. So the challenge is to get high quality plastic fraction for our compounders that would generate pellets eventually. That could be interesting because that's the compounder. We can see that they are like the link between the e-waste recycler and the manufacturer that will use it to create stuff. So how can I get high quality material? So the starting point for the recycling plastic is to target collection and see where I will get my material. And to transform them in fraction that can be processed separately for the compounder. Okay. The recycling of mixed plastic into clean recyclable plastic flakes is a challenge due to the high complexity of the plastic mixture. I have an example. Some equipment I dismantled recently. It was plastic with a coating of metallic paint. So strangely, the plastic was magnetic. So it was not reacting properly to its nature normally. You know, it should be plastic, should be floating, but in fact, this one, I could have removed it with a magnet. So you see, there are some special things that you never thought that could happen. It's happening. So there are presence of different layer of material, multi-layer stuff that are stick together. So that's part of the equation that makes it very complicated. So we already say that there are many types of plastics and presence of flame retardant and cadmium. So we discussed manual process, mechanical process, density process, and we saw that there are some specialized recycling facility that apply several sorting stage to separate the material with density separation. We saw that it's possible to get high density fraction that may contain the BFR stuff that we want to remove or the impurities. So what potential process could we put in place here in a situation of small budget? But I would say that first you need to establish the plastic needs of your compounders in your area, if there are some. Let's say there is a guy there who needs it for his customer. Identify the source of collection of the plastic. Make an inventory of what you can find in your loads. Would be interesting. Sort on a preliminary basis on the quick wins aspect that I mentioned previously. You know about Ppma, Ppma, plastic, this kind of stuff. Think to wash the plastic if it's very dirty to ensure good quality of a end product. May help to remove the dust from the shredding process, and like I said, think about managing the spent water. Determine a suitable method of sorting. So we have on the slide 56 the Ppma process that could be applicable. You know, and also size reduction for thin float should be in the area of 10 to 20 millimeter. Maybe your experience will tell you it's smaller or bigger, depending on what you will do yourself. But the thin float process shall lead to sorted fraction. When I was talking about the metal skips this year, this is an example. I've seen recyclers in the UK trying to make tests on this, and they were able to do something to separate the two fractions of ABS. So you can install maybe some valve and try to figure out something. Create your own design to make it useful. Get salt. Use the density table of slide 53 to create your recipe for your density. You can also eventually sample the resulting stream to confirm presence of BFR if you have a laboratory in your area, or maybe you can have an agreement with a compounder from analysis, or maybe he's taking care of that himself. So this is things to discuss. Look for solution for unsorted unknown material. We saw that on the graph of Ppma. At the end, we have a bunch of plastic for which at the moment I don't have an idea of the concentration of each material. So maybe there is more sorting that can be done, or maybe we need to find an alternative solution to use this material. And finally, store final material, ship it to your compounders, the safest way to not lose any value of it. So these are the things that you can do locally that you need to think about, that maybe you can organize. And when we talk about compounders, what these guys can do eventually. So you see, you have your sorting process, your material going to their milling process. They will probably wash as well themselves, because this is part of their process to make it more clean. They will have pigment additive if necessary to create like a paste that will be more easy to handle. They will probably store material or go directly to extrusion. After extrusion, the quenching is a kind of process to make it cooler. And then after that, you will have granulation, creation of pellets. And after the compounder, there is the molding process and the final product. So this is mainly the chain. And the e-waste recycler, you're located here at the beginning. So this is something found on the web that show. Oh, we have lost the reference of this little animation. I need to put it back. So this is the process of extrusion, you see. So it's feeding the system that will generate some wires of plastics. Here you have the cooling process, some kind of alignment, and here you cut it at the end to make some pellets. And this is an example of an extruder. And this is the wire coming from the extruder that is going to the cooling bath. At the end, you have the cutting machine that will generate those little pellets that can be transformed in new products. My colleagues with Lambel, they are working with a group of people in Brazil to develop some solution for e-waste plastics. So they have a project that is ongoing. So the challenge was so I will talk about this little pilot project in Brazil. There are some potential off-takers of recycled e-waste plastic in the country, but the recyclers can neither deliver to the expected purity level nor supply stable quantities. So there is, it's an issue. The knowledge on how to separate different polymers, and especially those contaminated with hazardous substances like BFR, is missing. Majority of companies use very simple, harmful to human health technique, which is burning and sniffing. The size of the country and the very scattered recycling infrastructure make transport costs very high. Yeah, Brazil is a big country, thus negatively impacting any reverse logistic undertakings. So over there are some solutions, next next Thursday, we are providing a training session in Brazilian. It's the same as we are doing today, but there are also some people directly from Brazil that will intervene in this discussion. So there's going to be many talks of what can be done in Brazil. And we are coming with some solution, how we can organize to have volumes for the compounders. So solutions, aggregation. There is Think Circular, which is a software developed by Circular Brain that will aggregate data on streams and volumes treated by the Brazilian recyclers. The volumes treated by different recyclers can be bundled together so that tonnage sufficient for off-takers are achieved. And the software can also act as a clearinghouse and offer credits, certificates to producers searching for environmental initiative. And searching for a compounder willing to use recyclates. This is in progress. Initial idea, compounder producing packaging for the domestic industry, but it was proved not viable due to high quality standard imposed by the specific of the industry, which means the product would have been contact with skin, so you don't want to have contamination from the plastic going in the product that could eventually lead to some issue with allergies, I guess, for the people or other worst disease. Another idea was producer of electric and electronic equipment that could use some material to be incorporated in their products. So they have slightly lower quality standard, but still ambitious because some products like fridge have contact with food. Producer global strategy is to use 50% of recyclate in their product by 2030. And presently it's only 5%. So there's a willingness of the producer to go in that direction, to get more recyclate fractions to be incorporated in their product. So the manufacturer, they have shared with compounders and what they need to get as a plastics. So they have developed technical specification. I could have shown you 100 pages of specification. We will limit ourselves to some pages because we will get dizzy. But there is a specification for every type of plastic with percentage of different additive and fillers. So there is many information we can find over there. But you can see as an example of a technical specification, people are looking at density, to the resistance to traction. They are looking at the flexibility of the material, is hardness, is resistance to impact, there is some index of fluidity, which means that when it will be mold eventually, what would be the quantity of mass that would pass per minute. And Teor de Cinza, I don't remember, I'm sorry, it's Brazilian, but I guess I have English translation later. I will explain. But you see, when a producer is providing his needs to a compounder, this is what we have normally. The test to be done with the methodology and the value to achieve with the material. So here we have, there is a lot of requests regarding polypropylene with the different level of filler or also natural. So because it is considered as a material that is very easy to for the extrusion process to be inject for the molding process. So it has a good processability with good melt, stability, good stiffness, impact balance, low odor, and taste transfer. So this is a material that for the Brazil project, mainly people are looking at the moment. And also here we have more information about the type of plastic with recycled material that could be included. You know. The test, I will explain to you some type of test that is done on the plastic. My understanding is the test will probably be done by the compounder because they are the one who needs to respect the specification. I guess also the manufacturer that is using the plastic is also doing quality assurance, doing the same test. So one of the tests is, I will explain some tests. There is some that are very interesting. There is the oxidative induction time. So this is a test where it starts with a nitrogen atmosphere and you heat it to 200 degrees C and you maintain the temperature along the test for a certain period of time. Then you switch the atmosphere to oxygen and you will see the evaluation of the enthalpy of the material over the time. And then there are some specification to meet. Approval requirement, it must withstand at least 100 minutes without showing oxidation. So that's the requirement. It should not oxidate for 100 minutes. The other one is thermo-oxidative aging. So the plastic is put in an oven at 150 degrees C. And then you will measure the loss of mechanical properties of the specimen compared to specimen that didn't go through this process. So you compare a sample not tested with the one tested. And the difference, tensile strength at breakage and flow, maximum variation of 30%. So all those factors, they should not vary of 30%. Chemical resistance. Chemical resistance. So we will immerse in a 1% detergent solution a sample at a temperature of 70 degrees for 500 hours. Wow, that's long. Evaluating the loss of mechanical properties after test. Again, you have some criteria to check: tensile strength, capacity of flexion, the impact test. You should not have a variation that is more or equal to 30%. So, and more tests that can be done: density, tensile strength, elongation and flow. Second flexion module. This is the measurement of material elasticity. The impact ISOD, we saw it on another page. It's they put a pivoting arm is raised in the air with at a specific height, and then it's released on the plastic sample, and the arm will swing down, hit the sample, and break the specimen. And the energy absorbed by the sample is calculated from the height the arm swim back in the air. So this is the way they do it. The melt flow index, defined as the mass of polymer in grams flowing in 10 minutes through a capillary. Okay, this is easy to measure. And then the Rockwell Tests measure the depth of penetration of an indenter under a large load compared to the penetration made by a preload, minor load. So mainly, yeah, you will see the entail inside the plastic sample, what it has created. And then the other one, I'll let you read this eventually. It's really for fan of laboratory, but these are the things that we need to meet. Now we have seen a lot of things, how to replicate the solution in your country. So yeah, I think we have said it many times. You need to see if you're in your country there are any off-taker able to take the e-waste plastic or a producer of electronic goods or people working together, you know, try to fit in between those people. What quality and quantities they need for that. What do you need to do to improve the quality of your output fraction? Because maybe you're already doing it. You want to get contracts with people. You need to see what can be done to make it better. Sorting, cleaning, removing impurities, securing steady supplies to the compounder. So we talk about organization of collect, or maybe you need to take a look at other options that can be done to improve the overall process. Maybe you may ask yourself, should I invest a shredder? What are the volume needed to have a shredder? It depends. Our friend of Prevents, they gave to me a link to a company called Precious Plastic. Those guys, they are providing small shredder that you can put on the table and you can generate flakes. And these flakes, they can be put in a machine where you can mold by mechanical pressure some nice things. I will try to click on it. I don't know what will happen. If we will lose the contact, but we will see. Skip verification. It's not very long. It's here. My connection is slow, I'm sorry. It's coming. It's something, what they are. Yes.
So we can see that you're playing the video, Mario. We can't hear it, but it seems like it's coming through. And now we see the shredder, yeah. So I can recommend that you just have a look at this website. They have, here you see the machines, right? Which some engineers who are passionate about making recycling machines, making them low cost, they've developed kind of like things you can build yourself, also kits, how you can try to build it. Of course, they're approaching it again from the packaging side, right? But I think you could apply some of the things like the shredders potentially also to some of the e-waste plastics.
Wow. It's because, Daniel, there it was no sound for you?
Yep, there was no sound for us. You have to share system sound.
Oh, sorry about that. Okay. Perfect. So voila. Come back to the from current slide. Okay. So that was Precious Plastic, quite interesting. Yeah, they seem to be able to do a lot of things, whatever the volumes. So it's a mechanical recycling process, shred, agglomerate in new products. Maybe what they don't say about this, maybe we need to see when you make the mechanical molding, is there any release of emission? Or do you need a permit to do that? I don't know. This is maybe things to be discussed with those people, or I guess Daniel provide me this link. I have some knowledge about them, so he can answer to you about contacts or info about them. So let's talk about elimination. Plastic discard, there is two types of plastic, the one with no value or that cannot be recycled locally, and the other one with persistent organic pollutants, heavy metals, cadmium, lead, brominated fire retardant. So we need to find solution for that. We saw that we can recycle through extrusion to make some pellets. By mechanical recycling, we can create new objects with like the people of Precious Plastic. There are also a trend in Europe that is chemical processing to transform the plastics and oil and eventually in polymer chain that could be used for new plastics. This is something in development. And thermal processing, you may as well have some pyrolysis, gasification, and fluidized bed that will transform the plastic in methanol. So you can create fuel, energy, and a new chemical eventually. And now we're talking about big plants, a big installation. And there is the energy recovery, where you can have or incinerator and cement kiln, where you can generate energy. But there are some conditions that we need to think about regarding this. Because when you burn plastics, you may have some toxicity in the smoke. So you need to have equipment with adequate pollution system to reduce the emission of any kind of heavy metal, POPs, dioxin, and furan. So yes, some presence of BFR and presence of copper can generate some additional issues regarding dioxin and furan, so it has to be managed in the proper incinerator. And ideally, if you manage to send your material to an incinerator with energy recovery, it's always the best. Could I find alternative for incineration in my country for plastics or hazardous waste? Cement kiln is often mentioned as a possibility, but there are some risks associated to this because of the nature of plastics. Anyway, I've made a small table there. Some polymers, some type of plastic, there is not really any risk. Like polymer containing carbon and hydrogen, like PE, PP, and polystyrene, they have good heating value, good for food production, and generally they produce clean exhaust gas. The one with oxygen, they have lower heating value. So we talk about PET and the Ppma. The one with nitrogen and sulfur, then we could have a generation of NOx and SOx. So we talk about polyamide and polyurethane. So you need to have good pollution control system. And the one with halogen, like chlorine, bromine, fluorine, then this is the one less popular for cement kiln and other type of incinerator, because you can have generation of corrosive molecule that could damage eventually the system of the process. So we talk about PVC and BFR plastic. So yeah, when you try to revise your possible option, probably the people will not take the risk to take the one that have PVC or BFR due to the risk of the emission, the risk for their installation infrastructure. Maybe their permit will not allow it. But it is those options, they need to be revised seriously with local authorities and potential taker of the material to make sure that no problem will happen. For sure, open air burning is not an option. It's another no-go. The other option, stock and export. What can be recycled or destroyed locally? It's probably very expensive and complicated to organize. To reuse and low-value products. If you have plastic that may contain BFR eventually, or maybe you can have a system where you can create pole and benches, very low-value product that could be used and for gardening, as gardening tool, but the long-term issue associated to this kind of product creation with material that is hazardous, it's the loss of traceability of this material. So now, for the moment, you know where it is. It's a bench, where a picnic table. But in the future, where will it be? It will get lost. There is no traceability of it, so it will go back in the nature and it will haunt us. So maybe better to get rid of it right away instead of keeping it, in the nature. And the elimination, if there is no possibility to get incineration with energy recovery, you can, if you have the chance to have a landfill for hazardous waste, protected and controlled for the underground pollution, it's the ideal. Like LPD liners with some layers of clay between the liners, and monitoring well to see if there is any release of pollution. It would be interesting. If you are dealing with a landfill like this, check for the validity of the license, if they can receive your material, if there are any internal controls performed to make sure that there is no problem or issue. For sure, we don't want to have like release of pollution to contaminate the phreatic water source around the area. That could, we don't want to create problem for the population. So yeah, there is many things to consider in this type of situation. And if you don't have landfill that you can use, honestly, I don't know what to say to you. Myself, I always have tendency to recommend to find the best solution and the best option. Maybe my colleagues have other idea what can be done. But for me, it's for sure landfilling. In a regular landfill, there is maybe some issue for the future. So when I say regular landfill, it's like as a household waste, you know. I always imagine the worst. Yeah, let's discuss. This is the end of the presentation for today. If there is any point and for which you need more explanation, or you may suggest us to analyze for future presentation, or don't hesitate.
Thank you so much, Mario, for bringing us through that and explaining all these different aspects. Really useful information.
I have no more voice, I'm sorry.
So I hope that you're able to maybe, yeah, maybe you can write your answers in the chat if you have no more voice at all. But yeah, I mean, some of the questions which might be kind of there for recyclers, I mean, we went through some of these testing characteristics from the producer side. I guess as a recycler, you can try to think, okay, you know, what should I invest in now? I can do, on the one hand, this manual or maybe a slightly automated processing line. I can maybe invest in a shredder. I can then look for a compounder, or I can then maybe look at trying to do some extrusion myself. In the discussions I've had about extrusion, it's very, very expensive to do this in Europe, and they're looking at huge, huge volumes. So I don't know if this is viable for recyclers to get into it. I mean, do you know anything around this? I've also unmuted Andreas, your colleague, in case Andreas has some comments on this. You know, what kind of equipment would be interesting to get into, and from what kind of volumes are we talking? Are we talking, you know, a few tons or thousands of tons?
If I may start here, Andreas speaking. It depends very much on the process. So if Mario in the beginning started with the manual sorting, of course, with manual sorting, you have no minimum volume. I just want to add a little bit here on the practical sorting. From experience, you don't have to identify each single plastic item, because we know from experience that so after a while the employees can detect the plastic just by experience, because specific models, specific brands have as always the same plastic. So you don't have to analyze each individual plastic type. But if you have experience, have done testing after some months, employees can identify, or basically they know the plastic after some time. So you don't need the identification of each individual unit. So you have, by experience, you can produce relatively clean fractions, just as a complement. So this is basically starting with 0 tons, basically with just an employee which you can dedicate to these volumes. And then if you look to extrusion, Typically throughput is here, you can maybe start with a monthly throughput of 100 tons, but that is really the minimum. With the shredder, it's normally even bigger because shredder capacity is higher than normally the extrusion capacity. But for extrusion, you need sufficient volume just to do proper blending. So you have always to mix sufficient volumes to have a constant quality and some fixed cost on that. What is again cheap is water tanks. You can do that already on a very, very, very small scale.
So in that case, possibly, I mean, yeah, as Mario was saying, probably look for a compounder. This compounder is already probably working with some primary plastic sources and turning that into the requirements that the producer needs. And then you're looking to kind of slot that into their process in a consistent manner that allows them to plan and actually then bring that into the required quality that the producer is looking for.
Yeah, basically it's both. You have to look at your input material. You have to know in which input material basically the right plastics are sitting, and then together with compounder to select the right stream. For example, also the type of e-waste collected in a country can differ a lot. So in many, let's say, developing countries, it's mainly IT. So it looks completely different. If you look to collection in Europe, you have a lot of small household appliances like vacuum cleaners. So in US, you don't find vacuum cleaners at recyclers. In Europe, you find them a lot. So it really depends a little bit on your input stream. And then basically, if you know your input stream and you have some knowledge about which plastic sits in which stream, you can identify relatively quickly which product can be manually separated and where you can generate sufficient volume for a compounder.
Okay, great, thanks. Let me unmute Joa, who has got her hand up. Go ahead, Joanna, with your question.
It was more like a reflection, in Latin America, I was thinking like, as a region, we are not Brazil, except from Brazil, everybody's kind of small. So I don't know, just bringing into the discussion that probably in regions like Latin America, where countries are quite small, and probably some compounder kind of hub would be useful for all of us. So recyclers in each country get to a certain point in terms of sorting plastics, but then the real sorting and getting to the qualities that are required probably should be done as a hub, let's say for Latin America, where all can bring our material there to this compounder that then probably will get all the volumes, the quality for producers or something like that. As a regional solution, because as a local might not be due to the technology, like how much it costs and the volumes required, probably might not be a good solution to have one per country, let's say. Just thinking out loud.
Thanks for that, Joanna. Andreas, I can imagine a similar situation is in Europe the case. I mean, do you have compounders probably in different countries, right? You're still muted if you're talking.
I was unmuted, sorry. Though also compounding industry is not distributed equally in Europe. So you have basically some countries who are specialized on compounding, and actually the waste is traveling quite long distance. It also that in the end the plastic, so if you have a good sorted plastic stream which consists of ABS, HIPs or whatsoever, it has already significant value. So value is maybe in the magnitude of 300-400 euros a ton. So you can put maybe up to 20 tons on a truck. So you can already travel quite a distance with that fraction. And I completely support that you need volumes, and looking to the size of some countries in South America, I think a more regional approach for the compounder will make more sense, because in a single countries you have not sufficient volume to fulfill all the quality requirements required for a compounder and re-injection of the product of the recycled material in the production.
Okay, great. Thank you. Any other reflections or ideas? I'd be interested if Arthur has had a look at this precious plastics or come into contact with it, if he has an opinion. I mean, my first idea would be, okay, yeah, it's interesting to start a little bit of recycling. Maybe it's working well for packaging waste, but there's maybe some issues there for e-waste plastics. I don't know if you've come across this initiative, Arthur. What do you think of it? Precious plastics.
Yeah, I think it's a very cool movement, and I know that like my ex-colleagues at Ppma had done some experiments with e-waste plastics and with a precious plastics group in Switzerland, and also tried to work with some precious plastic entrepreneurs in Ghana. And yeah, I think there are like many. I mean, it could work. I think nothing concrete yet, but definitely it's an interesting avenue to look at. Look at the precious plastics website if there are such entrepreneurs in your countries, and get in touch. And yeah, who knows? Maybe they are willing, or they are interested in these plastics that you find in e-waste, and it's probably not gonna. Oh well, who knows? Maybe it will lead to something of a substantial scale, or maybe not. Maybe it's just nice to just start to do something, try out things, and show also other stakeholders that yeah, some local solutions may be viable and need investment.
Great, thanks for that. Are there any other questions from anyone? Any specific questions you'd like to get answered on your issues that you might have? You have another 3 minutes. Feel free to put up your hand or put in the chat that you'd like to speak. Otherwise, I will slowly start to close the session. We're in the timing. Yeah, so as mentioned, we had last week battery training, and today we've been recording as well. So we hope to get these slides online and also share them with you, as well as the recording. And that should be in the next 1 to 2 weeks that we'll share all of that with you. And if you have any questions, we're also happy to take those. I don't know, Mario, are you happy for us to share your email with participants again?
Yes.
Okay, great. So then we can do that. Arthur, I don't know if you've shared your email in the chat as well, in case there's any interest from that side. But yeah, I think otherwise, thank you very much to everybody for staying with us through the whole training. I hope it was very useful for you, that you got a lot of good information that you can use. And yeah, we look forward to observing all of the plastic markets across the world starting and getting established with all of the great participants we had today. So thanks to you, Mario. I don't know if you have any last words, Mario?
Thank you. Thank you for your time and listening.
Correct. Okay. So no more questions, I don't think. Then that's it. Thanks very much to everybody, and have a lovely afternoon, evening, or week, wherever you are. Thanks. Bye.
Thank you. Bye-bye.